Problem 67, the instructions are construct a polynomial function that might have the given graph, but there's more than one answer that's possible. So this is just might have the given graph. So the important details here is that the end behavior is going down, down, so it needs to be negative. The end behavior is both the same direction, so the degree has to be even. There are 1, 2, 3 turns, so the degree has to be at least 4. And then we have zeros at -1, +1, +2, and there's a y-intercept at 1. Okay, that's a lot of details to meet. But do you see how I figured all that information from the graph? Okay, now we need to figure out how we can determine a polynomial function using that information. Okay. Oh, another detail, look at the point at 1. What do you notice about the multiplicity? Yeah, the multiplicity of that one has to be even on that one right there, right? Okay. So if we have these zeros, I'm going to cover up our graph for a minute and just use this information. I'm going to go ahead and start by creating factors for the zeros. So like x plus 1, x minus 1 squared, because it needs an even multiplicity, and x minus 2. See how I've created factors from the zeros, okay? Now I'm going to go ahead and multiply this out and see what I've got. So I'm going to multiply this part first. So that would be x squared minus 2x plus 1, right? And then I think I'll FOIL this one and this together, just because I've already FOILed the middle parts and I think I want to FOIL that one before I FOIL the whole thing together. So let's go ahead and do that. So x times x will be x squared, and then I'll have a positive 1x and a negative 2x that gives me a negative 1x, and then a positive 1 times a negative 2 is a negative 2 at the end. So at this point I had 4 factors, I FOILed 2 of them, I FOILed the other 2, right? Now I'm going to FOIL this stuff, which is kind of extensive. So we have x squared times x squared is x to the 4th. We have x squared times negative x is negative x cubed. We have x squared times negative 2 is negative 2x squared. We have negative 2x times x squared is negative 2x cubed. Sometimes I like to actually line up the like terms. So if this is negative 2x cubed, I'm going to actually line that up down here because I'm not going to have room to write it all across anyway. And then negative 2x times negative 1x is a positive 2x squared. And then negative 2x times negative 2 is a positive 4x. Last, I have 1 times x squared is x squared. 1 times negative 1x is negative 1x. And 1 times negative 2 is negative 2. Okay, let's combine all this together. So x to the 4th minus 3x cubed. Those cancel, but I still have that 1x squared plus 3x minus 2. Okay, so there's the zeros. The issue is the starting term is not negative. It is degree 4, like we said it should be, but it's not negative. So how can we deal with that? We can go through and change every number in the problem to a negative, and that will take care of turning it upside down. Okay? Now the last problem we have is that the y-intercept has to be at 1, and right now the y-intercept is at 2. How can we solve that? Divide everything by 2. That would work. That means our coefficients would all be like a half. So negative 1/2 x to the 4th plus 3/2 x third minus 1/2 x squared minus 3/2 x plus 1. So theoretically, would that work?
Yes.
Yes. Theoretically, that should be a correct answer, but like the instructions say, there's different answers that would work for this problem. There might be a different way to do this and have it still work out with the correct y-intercept. Yeah.
In the back it just has like
plus 1, or it has negative 1 half, and then in parentheses x plus 1, and then x minus 1 squared, x minus 2. So like you didn't have to do all of that.
Except, okay, I guess I didn't have to do all of that. So the back of the book, let's just write down what she said, says negative 1 half times x plus 1, x minus 1 squared. It might be in a different order, x minus 2. So you should recognize that as the first step I did up here. So that's the first step I did, but with a negative 1 half. Isn't that kind of what we did to it at the end? We multiplied the whole thing by a negative, and we multiplied the whole thing by a 1 half. The problem that I can see is that the purpose of me foiling it out was so that I could for sure tell what the y-intercept was going to be. I guess I could have left it like this and figured this out without foiling it out if I had just multiplied these terms together. So negative 1 times a negative 1, because there's 2 of them, is positive 1. And then positive 1 times a positive 1 is a positive 1. And then a positive 1 times a negative 2 is a negative 2. So instead of foiling the whole thing out, I could have just multiplied the constants and determined that the y-intercept would be negative 2. And I want it to be a positive 1. So in order to turn the negative 2 into a positive 1, I divide or multiply by a negative 1 half to turn that ultimate y-intercept into a 1 instead. Do you see how either way would work? So this and this are actually identical answers. They're just written differently.